Good afternoon to all. Myself, Arun Kumar. Today we are going to see fundamentals of op amp. So in this PPT, we are going to discuss about integrator and differentiator. One of the tool which are using for operation amplifier is op amp. So it is the circuit which will connect both sequential and combination circuits. So based on the operation amplifier, we can able to transmit the information from source to destination. So one of the tool which is used to transmit the information from source to destination is integrator and differentiator. So based on the integrator and differentiator, we can able to forward the signals to some other places with the help of some additional devices. So in this PPT, we are going to discuss how the integrator and differentiator functions has been performed with the help of circuits. So first one we are going to see operational amplifier integrators. So in this circuit, the 2, 3 and 1 pin will be enabled as a operational amplifier. So based on the op amp, the circuit input and output will be given. So here we are going to give the input as pulse waveform, then the output becomes another waveform like a triangular waveform. So based on the input signal, it can convert to the output signal with the help of this integration operation. So in this circuit, we can connect non-inverting and inverting terminals. So here the resistor is connected as a non-inverting terminal. So here the non-inverting terminal can be represented by minus symbol, and plus will be the non-inverting terminal. So here the minus symbol will be represented by inverting terminal, because inverting is nothing but minus. So automatically the signal can be connected as a minus, so it will be acted as an input signal. So here we are going to apply the input as pulse waveform, then the pulse waveform can be converted to a triangular waveform with the help of this capacitor circuits. So in this integrator circuit, the capacitor C1 will be acted as the integrator, and it can convert the pulse waveform into a triangular waveform based on the integration operation. So here we are going to calculate the how input and output waveform has been summarized. So in this slide, they are given about the calculation regarding input and output waveforms. So initially they are taken about input as input V in minus VA by R. Next, it is equal to the output voltage. The output voltage is nothing but minus C, because already the output can be connected as a capacitor terminal. So the characteristics equation of the capacitor will be minus C into d by dt. Then the output can be connected as a input also, because it will be acted as a loop, because the output of the capacitor terminal can be connected to the input of the terminal. So we can convert V naught minus VA. V naught is nothing but output voltage and VA is input voltage. So while the input voltage VA equal to the inverting terminal of the input voltage VA equal to 0, then the automatically the expression becomes V in by R equal to minus C into d by dt into V naught. Here we are going to calculate the value of the output voltage, because based on the output voltage only we can able to know about the concern pulse of the corresponding input signals, so that we can able to calculate the output voltage by V naught equal to minus V in by R into C into dt plus C, because it will convert as a integration option. Like here the capacitor will convert the integration operation of the input signal. So the final equation of the output voltage will be a minus V in by R into C plus C. And next one is op amp differentiator. So far we have discussed about the integrator and its operation. Now we are going to classify the operation of differentiator. The only thing, the one difference between the integrator and differentiator is the capacitor and the resistor terminal has been interchanged. If the capacitor is connected as a inverting terminal, then the circuit will be called as a differentiator. Likewise, the same terminal will be replaced in this circuit. The resistor can be connected as a series in inverting terminal along with capacitor terminal. The capacitor and resistor is in series in this differentiator circuit, where in the case of integrator, the resistor and capacitor will be interchanged. So here we are going to calculate the output voltage as have discussed in the previous integrator. The same calculation will be followed in this differentiator also. So the main function of this differentiator is to find the peak voltage or peak frequency of the concerned signals, and also it will be used for to calculate the to identify the waveform of the corresponding signal, because so in this differentiator function it will converted as many input signal into a different signals. It is also acted as a wave shaping circuits. The input signal has been converted into the required signal based on this differentiator operation. Next one is the calculation of the differentiator can be done by using the above formulas. So here the dq by dt is differentiation part. The differentiation is equal to the output is equal to the input as c into d by dt into v. Then the concerned current can be followed through the entire circuit is in equal to c into dv by dt input voltage. Here the final equation of the corresponding circuit is minus V out by RF, because the terminal inverting terminal is connected in this capacitor will be a minus, so that we can take it as a minus V out by RF equal to C into dV by dt. The final equation of the output voltage becomes V out equal to the same expression can be recalculated by minus RF into C d by dt into V. So here the some waveform of the differentiator can be calculated by the following ways. The input signal, if it is in a square signal, then it will become a differentiation by spike signals, because it is also known as a wave shaping circuit. Whenever the waveform as rectangular or signal or spike signal, we use this type of differentiator signals to convert such a signals. Sine waveform can be converted into cosine waveform, because so all those areas we are going to calculate the some frequency ranges or high speed range or high peak value. So in order to find those values, we may use this differentiator signal as to find out the constant frequency of the signal. So next one is assessment. Through this, we have discussed about both the integrator and differentiator. So one of the assessment here we are given about the condition, good condition of the differentiation and limitation of the differentiator circuit. The condition means the resistor R and C, the circuit should be much smaller than the time input signal. Next one is the capacitor Xc must be greater than 10 times greater than the resistor, so that the differentiator will be act as a proper circuit or good circuit. Next one is limitation. So there, even though some lot of advantages in this differentiation circuit, there might be some small the small drawbacks are there. So the drawback is, because we are using this differentiator circuit as a wave shaping circuit in order to identify some large amount of frequency. At the time, maybe some drawbacks, such a drawbacks are listed in this assessment. At high frequencies, the a simple differentiator circuit becomes unstable, because there are a lot of frequencies are generated at a single time. At the time, we may not catch the particular signal which one will be the right one. At the time, the frequency will be more when compared to the input signal. So at the time, there may be some drawback. The signals are maybe unstable, so that it may be oscillate. So we not able to identify the concerned signals. Next one is if it is high frequencies, then automatically the noise will occurs, and it may not be proper amplified. So we are going to make a signal as an amplified one, because the amplified is nothing but we are going to make a small signal into a strong signal, a low signal into a strong signal. So in order to have a high frequency signal, that kind of things will be happen. So these are some possible limitations of the differentiator circuits. Thank you.